Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we're going to be completing lesson number 25, and really quickly, lesson number 25 is much easier than the previous lesson. It's a very short lesson. Much of it you can read by yourself, so I'm not going to spend an incredible amount of time going through it. Optimization, definitely, it's a main topic, so it takes more time to do and to also go through homework. And then after that, we have another day-long topic, which is called inverse trig functions, and that, alhamdulillah, is going to be the end of calculus AB. All right? And remember, we talked about how this topic and the one that's previous to this, they're all still on the AP exam, because technically these are all topics that are supposed to have learned in the beginning of the course, not at the end of the course. Okay, so let's go ahead and begin. The topic of this lesson is called the two definitions of a derivative, right? And the two definitions of a derivative, we have actually learned them before. This is a second way of looking at it, because one of the things the AP exam makes you do is they make you think backwards, all right? So working backwards is not something that's very easy for students to do, especially when they're newly learning derivatives. So I just used to teach this topic in the beginning, but I stopped. It wasn't very successful, so now I teach the working backwards in the second part, okay? So I will share with you what type of AP questions are related to the definition of a derivative and the alternative form of a derivative. Most importantly, what you have to first do is memorize both of these definitions. You have to memorize both of them. You have to know them very well. There's going to be a question, right? Listen carefully. There's going to be a question that's going to either look like the one that looks like on the left, or it's going to look like the one on the right, okay? Now, let's start with the one on the left. This is called the definition of a derivative, and in the definition of a derivative, basically, we're finding a derivative but not using the power rule, the product rule, the quotient rule, the chain rule, you name it. We're going back to the definition, the old school way, the long way of doing it, if you want to call it the long method of doing it. So what we do is we take the limit of something, we do f of x plus h, f of x, and then h, all right? And we'll talk about all these things in a moment. Then when it comes to the alternative form, the big difference, you'll notice that this one says f derivative at x, this one says f derivative at a. And so basically, you can technically just use the definition and then plug a into it, and that'll make it look like this over here, okay? But essentially, we do have to know that second form of a derivative, and it's because of the idea of working backwards, inshallah. So the big difference between the definition and the alternate form is in the definition, you just take a derivative at x, whereas in the alternate form, you take a derivative at a. Now, notice another difference between the two. In the first definition, this is a limit that h goes to 0. Whereas in the second definition, this is a limit as x goes to a. So that's, I always tell students, that's like the number way to catch it, to be like, wait a minute, this is using this particular form of the derivative. These are both forms of a derivative. This is just known as the definition form. That's known as the alternative definition form, okay? Now, another thing you'll notice is this one has h in the denominator, that one has x minus a in the denominator. This one has f of x plus h minus f of x. This one has f of x minus f of a. All right, so they're written differently. One thing that might help you to memorize these is if you think about the alternative form as more as the mean value theorem form. That really helps, okay, to think about it that way. But you need to memorize both forms. And it's something that we've done before, but you're having to do it again for a specific reason that the AP exam talks about. So let's take a look at a question that's shown up in the past. All right, so take a look at example number 1. Example number 1 says, the limit as h goes to 0, 2 plus h cubed minus 2 cubed over h. Quite honestly, there's not much work that you do here. Okay, so here is what you need to realize, right? Just kind of stare at that problem for a little bit and ask yourself, now which form of the derivative is it talking about? Is it talking about the definition form, or is it talking about the alternative definition form, right? So if you go back up here, you'll notice that in my question, it starts off with limit h goes to 0, right? And if it starts off with limit h goes to 0, that must have been the definition of a derivative, because that's what the definition uses, right? So automatically what you want to do is you want to write down the definition right next to the question. It really helps, okay? It really helps if you just write down the definition right next to the question and say, well, that's f of x plus h minus f of x over h. That's the definition. And one more time, the reason why we're using the definition is because we notice that it says limit h goes to 0. So then you can start picking things apart. So for instance, you'll notice that, wait a minute, where there is supposed to be an x, instead of an x, there is the number 2, right? So in working backwards, what you need to do is think like that, right? And not just that, notice how this would have given you f derivative at x, so this question must be asking you for the derivative at 2, all right? So how do we go about this, right? Like what do I do now that I know that, right? So the first step that you do is you replace the 2's, you replace these 2's that you're looking at with x's, right? If you understand one example, you'll understand all of them, essentially, right? So you replace all of these 2's with x's, all right? So I went ahead and I did that, and here's what it looks like. It looks like instead of 2 plus h cubed, it looks like x plus h cubed. This instead of 2 cubed looks like x cubed, and this right here, it looks like f derivative of x. Okay, now it's looking more and more like the definition, right? However, now what you do is observe that in the definition, right, in the definition over here, this spot has the original function, right? It says f of x. So if you look at what we have now, where the original function is supposed to say be is it says x cubed. That's telling you something. What it's telling you is that means the function must be x cubed. So what we do is we kind of rig this problem, right? We kind of rig this problem to work for us in a different way. And what we do is we say, okay, we worked backwards and figured out what f of x was. F of x was x cubed. If they were truly wanting to find f derivative at 2, so what we'll do is we'll use the quick method of doing it. We'll say f derivative of x equals 3x squared, and therefore f derivative at 2 must be 3 times 2 squared. So once again, how did I do that? What I did is I looked at the problem, I replaced the numbers, the 2's, with x's and said, wait a minute, I know what this is. I know that this looks like the definition of a derivative, and the next thing I had to realize is x cubed must be the function. Why? It's because where x cubed is sitting, that's where the function is supposed to sit according to the definition of a derivative, right? So I simply show you the steps here and I'm done. The answer to this question is 12. And that's literally what the question is going to look like. It's not going to say f derivative 2. It's just going to say that. It's going to say, you know, find this. And you look at you'll be looking at that going like, wait, how do I find that? What does that even mean, right? So it means it's the definition. And as I told you, the thing that really puts your foot in through that door is this where it says limit h goes to 0. Okay, now here is an alternative way to do it. Okay, this is new this year. I developed another technique over the summer to help students in case they don't know how to think backwards with this, where they could still get some of those questions still correct. But please wrap your mind around working backwards, but here's an alternative way of doing it. All right, the alternative way requires our knowledge of L'Hopital's rule. Now look, you need to know L'Hopital's rule no matter what, okay? So when you're finding limits algebraically, they pretty much always come down to L'Hopital's rule. You guys saw that they have started putting L'Hopital's on free response as well. So here is example 1 again. Look at how many lines I take, by the way. I only take 3 lines, okay? But I'm going to use L'Hopital's rule. So here's what L'Hopital says. It says if you end up with 0 over 0 or infinity over infinity, but that's not going to happen right now, right? So 0 over 0, you can go ahead and take independent derivatives of the top and of the bottom. It does not say that you can use the quotient rule, by the way. Okay, it just says is take a derivative of the top, take a derivative of the bottom. Okay, so let's go ahead and try this. First off, when I plug the number 0 into h, right? So first thing that L'Hopital said is you have to evaluate the limit. So when I plug a 0 in here and I plug a 0 in over here, I end up with 0 divided by 0. So because 2 plus 0 is 2 cubed, and this right here is a typo. That's supposed to be 2 cubed as well, as it's written up here. So 2 cubed minus 2 cubed gives you 0, and the h is a 0. So there you go. You have the indeterminate form. The indeterminate form is basically 0 over 0. All right. Now, what do I do with that? Well, if I take a derivative of the top independently, to take a derivative of the top means for this first piece right here, I must use the chain rule. The chain rule says take a derivative of the outside, keep the inside the same, and then take a derivative of the inside. So that's what that looks like. 3 times 2 plus h squared times 1. And what's the derivative of this, of 2 cubed? Well, the derivative of 2 cubed is simply 0. So when I do that, here's what happens. 2 plus h squared times 1 shows up right here in the top. And again, the derivative of the bottom of h is simply 1. Notice I did not use the quotient rule, okay? Not the quotient rule. So this is a mistake that some students kept making last year. They thought that every time something is written as a fraction, it's a quotient rule, and I understand. It's kind of ingrained in your head to do that anyway. And then what L'Hopital said is go ahead and re-evaluate. Plug that number 0 in again and see if it works for you. And this time when it works and it gives us the number 12. And notice that in the previous question, we also had 12. So from here on out, I'm just going to have a number of examples that essentially go towards that same exact objective. And I'm going to go ahead and go to example number 2. So take a look at example number 2. All right, if you want, you can even pause this video and you can try it by yourself. And first do it in the regular format of doing it and without, using L'Hopital's rule. So you got to look at this and be like, okay, which definition is this? Is this the definition of a derivative or the definition using the alternate form? And quickly, the first thing you should look at is right over here, and that should tell you, wait a minute, this is the definition, right? So if this is the definition, the next thing that we learn to do is we learn to remove the numbers, the 5 over here and the 5 over here, and replace them with x's. So in this line over here, I go ahead and in this over here, I replace the x's. I replace the 5's with x's. And again, you stare at that long enough to realize that, wait a minute, according to the definition, that is the spot where f of x is supposed to sit in. And so that means that the function is natural log of x. And the whole point of this question was to find f derivative at what? At 5. So what we just did is we rigged this problem. We said, okay, I know what f of x is. F of x is natural log of x. I know that f derivative x is therefore 1 over x. And if you want the derivative at 5, I'll go ahead and plug in the number 5 into this. And so here you have it. You end up with f derivative 5 is equal to 1 over 5. Okay? And so the answer to the question, as convoluted as it seems, is simply it's asking you to take the derivative at 5, and we did that, and we ended up with the answer 1 over 5. Now let's quickly try this again with L'Hopital's rule. For this, you'll need to know what is the derivative of a natural log using the chain rule, and at this stage of the game, you must know this very well. So if you need to pause and go find the derivative of a natural log, by all means do so. So here goes. First off, I plug in the 0. Okay, that's what L'Hopital said. He said plug in 0, see what you get. So I plug in a 0, I get natural log of 5 minus the natural log of 5, which gives me 0 over 0. Okay, now taking a derivative of natural log of 5 plus h, if you have forgotten, the natural log of u, when you take its derivative, is u prime over u. And so the derivative of 5 plus h is 1 over 5 plus h. And the derivative of h is 1. So once again, you plug in the number 0 into this derivative, and this time you end up with the answer, which is 1/5, which is not a surprise. But again, look at the amount of work that would entail in that first piece versus the second piece. But I'll tell you right now, one of the objectives of the AP exam is for you to be able to think backwards. Okay, so there is a reason why I'm teaching you both ways of doing it. All right, this question has been on there often, but this question is also on there. Okay, and this one is on there more often in that they're trying to get you to think backwards. That's part of the objectives of the course. Okay, now let's try something a little bit harder. Okay, and first off, I hope that you've caught on to the pattern. We look at this spot right here, and we're like, okay, this is the definition of a derivative that they're supposed to be using here. All right. Now, I keep forgetting limit h goes to 0, so there's that. Now, if you look at this long enough, you'll notice that, wait a minute, there is a 5 pi over 6 where the x is supposed to be. So we know that that's 5 pi over 6, right? But one of the problems that we're experiencing here is it just says a half where the f of x is supposed to be. So there's a problem there. They must have evaluated the function, right, at 5 pi over 6 and then come up with a half. In other words, we're saying that the derivative at 5 pi over 6 is really what the question's asking. Now, when you come to replacing, you might not get it just yet, but take a look at those two previous problems. Look, this one said a natural log of 5 plus h minus the natural log of 5. F of x plus h minus f of x. This one said 2 plus h cubed minus 2 cubed. So x plus h cubed minus x cubed. In other words, we knew that the function here was x cubed. We knew that the function here was natural log x. So the function here is not as clear because it says the sine of 5 pi over 6 plus h, but then it says minus a half. So if you put the pieces together, you realize, wait a minute, that must have been the sine of 5 pi over 6. And yes, I know that's critical thinking, but that's the thinking backwards that we need, right? So this must have been sine 5 pi over 6 plus h minus the sine of 5 pi over 6. And not just that, if you go to 5 pi over 6, which I don't mind doing for you, okay? So first off, 5 pi over 6 in degrees, right? 1 and 30 is 150 degrees, right? And if you find the sine at 150 degrees, right? So the reference angle is a 30 because you traveled 150 here. And the sine at 30 degrees, right? The sine at 30 degrees, if you look in your 30, 60, 90, you'll find that the opposite over the hypotenuse is 1/2. And that is why we're not looking at the sine of 5 pi over 6. We're just looking at a 1/2 this whole time. By the way, sine is positive in this quadrant, so it makes sense that the sine of 30 and the sine of 150 are both positives. Okay, so having said that, now we understand why this said a half, right? So moving forward, the question isn't done yet. We still need to replace the 5 pi. We need to replace the 5 pi over 6 with an x. So I go ahead and I do that, and now it makes a lot more sense is if you have it looking like this over here in this step, right? What is the question really asking you? Well, you know that the function is sine x now, right? The function is sine x, and you need to take its derivative and then plug 5 pi over 6 into that derivative. So I go ahead and I do something like that, right? Well, what's the derivative of sine? It's cosine, right? I plug in 5 pi over 6, and it's a good thing that I showed my work over here because it's not going to take any more steps. We simply need to find, at that same exact situation that we were at before, we need to find the cosine at that point. And recall, cosine is negative in the second quadrant. So when you find the cosine of, of 30 degrees, that's going to be adjacent over hypotenuse, which is root 3 over 2. However, considering how this is in the second quadrant and cosine is negative in the second quadrant, what that means is your answer should be negative root 3 over 2 in the end. So there you have it. So that one was a little bit more involved and it was a little bit harder. Again, let's go ahead and try this again using L'Hopital's rule. So first off, I plug in 0 into the function. Okay, so I plug the 0 from the problem into the function, step number 1. I end up with sine 5 pi over 6. Now we just discovered that the sine of 5 pi over 6 is a half. We're subtracting a half. That was already in the question. And that gives us enough grounds to use L'Hopital's rule. So in using L'Hopital's rule, yes, you need to take this. This is always going to be the chain rule. Remember, the derivative of sine is cosine, so the derivative of the outside. Keep the inside the same, and then derivative of the inside, like that, right? So that's how I ended up with this step over here. Again, I reevaluate, right? I plug the 0 into the h, and this time when I do that, the question really becomes the cosine of 5 pi over 6, and that is why you end up with the answer that you end up with, negative root 3 over 2. Bismillah, let's keep moving. Now, you want to take a look at this question. This one's being a little bit more interesting. It's saying that if the limit as h goes to 0 of f of x plus h minus f of x over h equals 2x plus 3, what is a possible equation of the function? So this is what I meant by you have to know what the definition stands for, right? You have to know how to use it backwards. So now give it some thought. We know that the definition of a derivative, all it does is it's a longer way of telling us. This is the 4th or 5th time I'm telling you, just in this lesson, it tells you the derivative. In other words, they're telling you a derivative equation, and they're asking you, what's a possible function that this may have come out of? Well, to go from a derivative back to a function, we know that we can integrate the derivative. And yes, we'll have a plus c in the end, but that's not really our concern. What our concern is, can we find some function that would fulfill this purpose? So the integration of 2x is x squared, the integration of 3 is 3x, and you can leave a plus c, meaning you can put anything that you want over there. You could leave that as a 0. They were just saying give us one possible equation, right? And we found one possible equation. One possible equation is x squared plus 3x, and that's all there is to that problem. Okay, now notice that there is no using L'Hopital's rule here. Okay, so please realize L'Hopital's is a way of going about a specific question. It does not get the job done for everything, inshallah. Okay, now by all means you can, I usually pause here and I just give students a minute each to try the problems that I give ahead. These are all, by the way, taken off of AP problems. So really quickly, example number 5, it says e to the power 2 plus h minus e squared. So if you listen to my language, I just said e twice, didn't I, right? And again, notice how this does say limit as h goes to 0. So just begin by writing down, once again, just write down the definition of the derivative. I know this is becoming very repetitive, right? But I feel like there is some merit to that. If you learn it enough number of times, when you really need it, which is on the AP exam, you'll be able to figure it out. Okay, so here is what that setup looks like. And again, you'll notice that really where there's supposed to be an f of x, there's an e squared. And where there's supposed to be an f of x plus h, there's a e to the power 2 plus h. All that can mean is the function must be e to the power of x, right? So the function must be e to the power of x, like this over here. And they must have had a 2 in the spot, right? They must have had a 2 in the spot of the x. So we go ahead and we replace it, right? We bring it back to its original thing. And so f of x is equal to e to the power of x. Well, what is its derivative? The derivative of f of x, the derivative of ex is ex, right? So we have its derivative right over here. Now plug the number 2 back in, and coincidentally, you end up with e squared, and we're done with that. Can you use L'Hopital's rule? Absolutely. And it's a wonderful time to just kind of go over chain rule again right before, you know, we start getting ready for the AP exam. Some of you have already started, alhamdulillah. So e to the power of 2 plus h, if you don't know the derivative of eu, which I highly doubt that somebody doesn't know it, but, you know, eu times u prime. And so as we take the derivative of the top, right? As we take a derivative of the top, so I'm looking over here, I skipped a few steps. We take a derivative of the top, we end up with e to the power 2 plus h times 1, right? EU times u prime. And remember, the derivative of e squared is simply 0. So, and the derivative of h is 1. Now, when we plug 0 back into there, we end up with e squared as our answer, okay? Now, example 6, I'm going to slow down a little bit. And now think about, why am I slowing down all of a sudden for this? And it's because, what definition are they using now? All right? They are using the alternative definition, right? Here is the one that, oops, sorry, I put the 6 in where the a is supposed to be, but that's telling of what's coming. F of x minus f of a over x minus a. Now again, this one's been a little bit easier for students to tell in the past. Just, you know, I don't need to scroll so far down. Just look at it, realize that, wait a minute, where that spot is actually natural log of x. And if you were able to make that connection, that's all the connection you really need to make. The question is asking you for f derivative at 6. What you do is you say, well, if f of x is natural log x, I'm going to take its derivative, and I know that the derivative of natural log x is 1 over x, and then I'll plug the number 6 into it and end up with 1 over 6. That's all there is to it, okay? Why are we looking at this first row still? Because you're just basically matching everything up. Just make sure that everything looks exactly as it's supposed to be before you choose to use the definition, the proper definition, right? Again, the notes are, you know, they're present for you, so you're welcome to look at it. Well, you might be wondering, wait, can I use L'Hopital's for this? Well, let's take a look. I plug in 6 initially. Remember, L'Hopital said evaluate it first. And I end up with natural log 6 minus natural log 6. So guess what? We can use L'Hopital's rule because we have indeterminate form. Well, what's the derivative of natural log x? 1 over x. What's the derivative of natural log 6? It's just a constant, so it's 0. And this is how easy it is. Plug the 6 in. And by the way, the derivative of x minus 6 is 1. Plug the 6 in, and you get 1 over 6 once again. Okay? All right. This, again, because it's using the alternative definition, right? I want to slow down here a little bit. I don't want to rush it. So limit x goes to a, f of x minus f of a over x minus a. That's what we go into this problem knowing. Now take a look where the f of x is supposed to be, the secant x is, where the a is supposed to be, the pi is, and where the f of a is supposed to be the secant of pi is. So we can tell that this is certainly the alternative definition. But remember, what you extract out of this is two things. What's the function, and what is that constant that they're interested in, so we can go ahead and evaluate it there, right? So the function that you should have realized is actually the secant of x, because that corresponds to that. And they are interested in you taking a derivative of this and plugging what number? Pi into this. Okay, so what's the derivative of secant x? You may pause and check, but the derivative of secant x is secant x tan x. And so I'll just scroll over here just to make things a little bit quicker. So here is secant x tan x. And now I'm going to go ahead and plug pi into this derivative. That becomes the secant of pi times the tan of pi. Now, just a little bit of trig for you. The secant of pi is the same thing as 1 over cosine of pi. The cosine of pi being -1 makes it 1 over -1. The tan of pi is simply 0. So the answer to this question actually ends up being equal to 0. Can we use L'Hopital's rule? You know it. You can certainly use it. You'll end up with that same exact situation, and you'll end up with the same exact answer as well. You're more than welcome to check it by yourself, inshallah. Okay, now, number 7 is a bit of a tough one, okay, because it says find the value of a in the first quadrant. Okay, so let's figure this part out. First, you got to figure out which definition are they using. Is this the definition, or is this the alternative definition, right? So far, I think you may have caught on to the pattern This is the alternative definition. However, they're going a little bit more with this, and that's why I'm including this in my lesson here. You know, based on what you learned in that previous few examples, is f of x must be the tan of x, right? For sure, f of x must be the tan of x, because look at where f of x is, look at where that is. But first off, replace the a with x so it looks exactly the way that you want, right? But this time, instead of asking us for a derivative, it's telling us that the derivative is equal to 2, right? So you know that the derivative of tan is secant squared, right? So they're telling you that secant squared x is equal to 2. Find us the value of a in the first quadrant, right? How do you find that value? Well, to anybody who has forgotten, how do you solve these equations to actually get to an answer? Bismillah, let's go ahead and try it. Well, the first thing that you would say is, basically, if secant squared x is equal to 2, right? I start right here, Bismillah. I start over here. So if secant squared a is equal to 2, that means cosine squared a is equal to 1 over half, right? Because recall, secant of theta is equal to 1 over cosine of theta. In other words, whatever secant was, just flip it over and you'll have cosine. So if the secant of a secant squared of a is 2, then the cosine squared of a is 1 over 2. Okay? Now to solve for the cosine, right? So this is where we're at now. To solve for the cosine, notice how it has a square on it, so we'll need to take a square root. And when we take a square root, we end up with positive or negative half. And when we end up with something like that, basically we need to work backwards and to solve for a. So to anybody who has forgotten how exactly do you solve these, once again, you basically ask yourself, where did I find 1 over root 2, right? Where did I find 1 over root 2? You found 1 over root 2 in the 45, 45, 90, right? That's where you found 1 over root 2. And so you're basically making a reference angle of 1 over root 2, right? You're making a reference of angle 45 degrees, sorry, in that first quadrant right there. Okay, that's your 45 degrees. And so your answer, because it's asking you for the question in the first quadrant and not the one that is in the fourth quadrant, so we'll leave out the fourth quadrant for now. Okay, it's not really asking us for that. So the answer that we get is pi over 4. In other words, this is pi over 4 right here. And when you fit it in, and you had found the derivative at pi over 4, you would have found that the answer does give you 2. Okay? Now, generally, we pause in class, and I have you guys try these examples. So please, please, please try these examples. Get used to it before you try the homework, okay? But that is essentially it. I have some older AP problems. They are actually quite relevant. They are actually very relevant. So take some time, look at these problems over here, and try them as well, and see how you would do with these older problems. Some hints that I'll give to you, Bismillah, is in this example, ask yourself, is this the definition or the alternative definition? Look here, this must be the alternative definition. Step number 2, notice how they both have 8, right? They both have a half, except the difference is this one on the left says a half plus h, whereas this one says a half. So have you been able to figure out what the function is? The function, okay, so if you can't figure it out, here, let me write for you everything, but with the half replaced, maybe that will help you, inshallah. So 8 times x plus h to the power of 8 minus 8 times x to the power of 8 over h. All right, so again, have you been able to figure out what the function is? If you look right here, that's where the function lies, okay? That means the function must be 8x to the power of 8. They want you to take its derivative, okay? They want you to take its derivative, and then when you take its derivative and you end up with 64x to the power of 7, they want you to plug in the number a half into it, all right? So when you plug in the number half into it, it'll become f derivative of a half, right, is equal to 64 times 1/2 to the power of 7. Now, you do need to find the power of 7, 2 to the power of 7, without a calculator, right? So 64 multiplied by 1 over 2 to the power of 7. I know that 2 to the power of 5 is 32, 2 to the power of 6 is 64, and 2 to the power of 7 must be 128. So this is 64 over 128, and that is going to give you the answer of a half. All right? If you use L'Hopital, it would certainly work for you. Okay, it would certainly work for you, and that's why I really recommend is be familiar with how to work with these problems over here in both respects. But one thing that you will need to be able to do, though, is you will, even for L'Hopitals, you'll need to know how to replace the half with an x, right? So even then, you need to know what definition is this so that you can replace the halves with the x's. And then by all means, you can try Bismillah L'Hopital's rule, but just kind of looking at it, that looks like it's going to be quite painful to do. In second thought, I think L'Hopital's actually, looking back at my examples here, I'm sorry to confuse you, just a bit of fatigue here, but I think that L'Hopital's might just work for you if you do it even without plug. Yes. So here, I take back my word. So you don't need to replace anything. You don't have to replace the 2 with an x. You could just go ahead and start using L'Hopital's with that problem, and you'll get the job done. So minus what I just said there a moment ago, all right? I don't want to go back in the video and delete it. So you don't necessarily, if you use L'Hopital's, you don't have to replace the half with an x, okay? So let me leave a note here. If using L'Hopital's, right? If using L'Hopital's, then you don't replace 1/2 with an x. All right, I apologize for that. One last question. Take a look at this one over here. It says if f of x is equal to ex, which of the following could be the f derivative at e? Now, you're probably thinking, why don't I just go ahead and take a derivative, right, which is ex, and then plug in e into it and be done with it, right? It's because, look at all the questions. All the questions are actually written as definitions, right? So you need to definitely know, how am I supposed to write this out? So once again, notice how all of them say h goes to 0. So I would really recommend to you, strategy is to just say, all right, f derivative x equals limit as h goes to 0 of f of x plus h minus f of x over h, right? And now notice how all of these have h in the bottom. So that's not the issue. That's not the problem. Then the second thing that you want to do is you want to fit everything in. So if f of x was equal to ex, then f of x plus h should be ex plus h. All right? So this spot right here should be e to the power x plus h. This spot right here should be e to the power of x. And finally, the last thing that we need to do is we need to plug e into this derivative. So we want to find the derivative at e. Now, how is that going to change what we have here? Limit h goes to 0, and where it says e to the power x plus h, it becomes e to the power e plus h, and where it says e to the power of x, it becomes minus e to the power of e, so that looks very interesting. And then on the bottom, you have an h, right? So the correct answer in this situation would be the letter E. So very interesting questions that they've asked in the, this is from the 60s if you recall, but I felt like it was really useful to go through these. So guys, I've been through a number of these problems with you, and inshallah you're going to find the homework to be a lot easier this way. Um, so good luck on doing the homework. Remember, the homework and the classwork are both due together for all these lessons that we're doing here, because the classworks are so negligible. It's just better to just get them done all in one. Good luck to you, inshallah, and assalamu alaikum.